All right, let's move on. So example number 1, the relationship between the graphs of sine and cosine. All right, and so when you first take a look at the graphs of sine and cosine, you can definitely tell that there's some similarities between them. All right, and so you can see on the right, you're given the graphs of sine and cosine. And so first things first, I want you guys to label which is which and then complete the following, okay? So make sure you guys copy this graph down onto your notes, and I want you to tell me which one is which. Which one is the sine function and which one is the cosine function, okay? And so then after it says, describe how the cosine function can be translated to obtain the sine function and vice versa, right? Then use your observations to complete the identities 1 and 2 below. But we'll do that at the very end, all right? Because just by looking at these graphs, right, it looks like if we were to like move one of them a little bit to the left, or if we were to move one a little bit to the right, they would line up with each other, and they will line up with each other perfectly, and they would be sitting on top of one another. All right. And so I want you guys to decide how much would I have to move one of these graphs to the left, or how much would I have to move the other one to the right so that they line up with each other perfectly. Okay. All right. Cool. So let's take a crack at this. All right. So I'm just gonna label which one of this is sine and which one is cosine. So the dotted, I'm gonna do it right here. The solid line. Why is it moving? Okay, there we go. Okay, the solid line one, that's gonna be sine. That is sine of theta. And the dashed line one, that is cosine of theta. Right? How do I know? Because the dashed line one starts off at 1, goes down to -1, and then goes back up to +1. The solid line curve starts off at 0, goes up to 1, down to 0, down to -1, and then back up to 0. Right? So that's how I was able to tell which one was sine and which one was cosine. Right? And then it says describe how the cosine function can be translated to obtain the sine function and vice versa. All right. And so let's start off with the cosine function, right? How can the cosine function be translated to obtain the sine function, right? And so we're going to write. I'm gonna go over here. Why did that happen? We are going to write by moving the cosine function pi over 2 radians to the, let's see, cosine, I would have to move it to the right. Yeah, by pi over 2. Right, by moving the cosine function pi over 2 to the right, we obtain the sine function. We obtain the sine function, right? And so for sine, right? So, or for cosine, by moving sine pi over 2 to the left, we obtain the cosine function. All right. So to summarize, starting with the cosine function, if I were to pick it up and move it pi over 2 spaces to the right, it would line up perfectly with our sine function, and vice versa. If I were to take the sine function, if I were to pick it up and move it pi over 2 spaces to the left, it would line up perfectly with the graph of the cosine function. Okay, cool. And then B says, is the cosine function even, odd, or neither? How about the sine function? Use your observations to complete identities 3 and 4 below, right? And so we talked about even and odd functions briefly before. And so try to remember your guys' knowledge on what makes a function odd, or what makes a function even, or what would make it neither, right? And so there's two ways that you can prove that. You can prove it algebraically, or you can prove it graphically. Okay, and so we're gonna do it graphically because it's much more easier. All right, so if a function is even, right, its graph must be symmetrical about what, or must be symmetrical about what? Nice. Hopefully you guys picked that. If a function is even, it must be symmetrical about the y-axis. And if a function is odd, it must be symmetrical about the origin. All right. And so for the cosine function, we can see that it is symmetrical about the y-axis. So we're going to say that cosine is the even function. So cosine is the even function. Right, so that must mean that sine is our odd function. Sine is the odd function. All right, cool. And then now we can fill in these identities. All right, and so for the first one, we know that cosine of theta minus pi over 2 is equal to sine, right? Because if I were to pick up the graph of the cosine function and move it pi over 2 spaces to the right, it will line up perfectly with the sine function. And if I were to take the sine function and move it pi over 2 spaces to the left, it will line up perfectly with the cosine function, right? And then for 3 and 4, this has to do with the even and odd of the blah. Let me rephrase that. For number 3 and number 4, this has to do with the fact that cosine is an even function, and the fact that sine is an odd function. So since cosine is an even function, we can say that cosine of negative theta is equal to cosine of theta, and sine of negative theta is equal to negative sine of theta, right? And this is because cosine is even and because sine is odd.